Hello. Okay, it seems that I should be live. So, without further ado, hello everyone. I am Lazen Lai. Today we are going to be doing Step Support Program Foundation Module Assignment 6. Boy, what a wordful. So, we're just going to be getting on with it immediately without any further commentary. I'll see if I can just do uh, the warm up fairly quickly because I am quite late, so I need to make up on time and get this bit done as soon as I can. So the first question is find the value of this, which hmm, let's see if we can observe any kind of pattern. So we can separate this into this, and the rest of it ignore. So then this becomes 2 dividing over 2. So we know that this is simply this, so it's free. And I suspect some kind of similar pattern follows for the others. So yeah, this crosses out into 5 divided by 3. And again, same thing applies. So by proof of it looks like it, we are going to guess that this is going to be 97. So 3, 1, 5, 3, 5, 9, 7, cross, 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 cross. The answer is 9. Now we can find the value in terms of n of this number. Well, now we know that the sequence goes 3, 5, 7, 9. So the value in terms of n would be very simply whatever the n term is times 2 plus 1. Which does indeed work out. Now let's go solve the simultaneous equation. Okay, well, adding 2 and 3 together transforms this into c. 2c equals 8, which means c is 4. If c is 4, then we can do the same thing for 1 and 2. 2a equals 2, so a is 1. Therefore, b is 1 plus b minus 4 is 2. This is just one of the things up in. And then this becomes 5. So that is the answer. Now let's look at the simultaneous equation where it's a little bit different. So with that, we still know, in fact, that C is going to always be 4 because 2 and 3 remain unchanged. However, A and B are different. Oh no. So combining 1 and 2 becomes k plus 1 equals 2. K plus 1a equals 2. What do we combine? 1 and 3. That means k minus 1 equals a. Let's do b equals to 10. Now at this point we may as well take the information that we gleaned from 2 plus 3, which delivers this. Oh, no, sorry, I did the negative by accident. So now we've got these 3 equations that we've got to figure out if there is a value of k for which the equations have no solution. So these bits are linked. So we can take this, throw it over here, sub it into 1 plus 3. No, sorry. Yeah, okay, that makes sense. So now what we have are just these 2 that we have to consider. And we know that this is going to be 2n plus 1 divided by 2 because of what we already obtained from above. Wait, no, that's completely wrong. What I'm on about. This is a pain. Is the same? Oh wait, no, this goes over here. Did I get one of these removed? Clearly something's going on here, so we've got to go for that. Maybe 1 plus 3? What is it? Oh, I missed out the fact that this is negative. This is negative. So actually, yeah, this should be, in fact, bk plus b, 4k 6. So both of these are the same, which means that we can then do some mathematics to figure out the answer. Does not help. I already spent like an amount of time wrestling and putting on today. I don't have the energy for this. But let's continue. Maybe I don't need to construct any of this stuff. Maybe it's just like this. Does feel a lot simpler, isn't it? I don't get it. What is going on? Oh wait, no, I'm dumb. Oops. That's basically the same conclusion as we can draw from this, so we can just remove that as being fake consequences. Oh wait, no, I already solved it like a while ago. What the fuck am I doing? I'm like half awake right now. This is the answer. And this is the answer for B. What am I doing? Oh my days. Okay, I don't. What the fuck? Okay, here's an easy question. Arrangements. Arrangements are easy. We love arrangements. In how many ways can Ben, Elsa, and Charlie arrange the letters in their names? What the fuck? Let's just look at the example. Yeah, okay. Okay, so it's just that. Okay. That's not that bad. So Ben is 3 factorial. Elsa is 4 factorial. Charlie is 7 factorial. How many distinct ways? Sorry, why not distinct by default? What's the difference between a way and a distinct way? Oh, because they have repeated letters. Yeah, makes sense. Oh, yeah, okay, fine.
Here's to working every night, get new wrongs and make them right. It's a circle and it's a long way round. But maybe I'll bend it out of shape and break it in half, then I'll escape and wander around where the top is always down. I'm dreaming of a Rolls Royce Phantom life, where everything is golden rich.
Okay, I'm just gonna read the thing. So yeah, the first one is fairly obvious. It's factorials. Repeated names. How do you do this again? Ah, I see.
Maybe when my gold has lost its pride, there's no one there to hold me dead of night, and nothing that I saw
Okay, fine.
give me that. I guess I'll take my Rolls Royce Phantom back. All alone, I kept it all inside. Always walked one step behind.
I'll just write E, right? E has 33. David has Mr. S has 7 factorial divided by 2 factorial.
Just begun. I've just begun. Yeah.
marshmallow. The 2 M's, 2 L's, 2 A's. I think that's it. So, yeah. She holds, it's feeling like we've been here before. We're both so broke, that's something that'll keep us afloat. Don't walk too slow, we can't keep falling deeper again. Came too close and the taste so far from pure. A rush of blood, but we search for so much more. We've all been here before. We've all been here before. Okay, so finally the step question has arrived, and the step question I'm going to start talking for because, let's be honest, the preparation was pretty rote, so it wasn't that interesting. It was just applying the stuff you got from below. So, without further ado, let's start looking at it. 47231 is a 5-digit number whose digits sum to this. Just to warm up. Okay, so it's just a bit of probability. We should be fine. So how many ways are there to make 43? So, first of all, let's determine that the max value of 5-digit sum, or at least summing together 5 digits, is 45, because 5 times 9, right? And so this already means that there is a pretty significant lower bound on the number of, how do you say it? The number of 43s that can be generated, because it's already pretty close to the maximum, so there shouldn't be that much deviation. And so let's think about how we can reach 43. Now we can do this in, I think, a couple ways. We can do this either by reducing one of the 9s into a 7, so 79999, or reducing 2 of them to 8, so 88999. Yeah, and that's pretty much true. So, for the first one, obviously there are 5 such cases of this. That's pretty simple, right? Because you can put the 7 here, and etc. For the 8s and 9s, however, we are going to have to do arrangements. So, the way that we would want to model this is perhaps, say all of these are unique, right? So how many combinations does that give us? That gives us 5 factorial. And then we begin to look at the combos where there are duplicates, right? So the 8s are, for example, the 8s are in the same position. So for looking at all of the combinations, there's always going to be two duplicates, right? Two of the same, because there's going to be, let's say that this is 8-1 and this is 8-2. So there's going to be one combo that looks something like this, right? 8-1, 8-2, and then 999, 9193, and then here. And then there's going to be another combo, which is the exact same, but this time, since we're treating the numbers as unique, the 8-2 becomes this one, and the 8-1 becomes this one. So these two are the same. So the way that we can get past this, the way that we can kind of solve this, is by dividing this by 2, or 2 factorial. I mean, we just write it as 2, it doesn't matter. And yeah, and then that gets rid of the extra one and means that this is perfectly unique. And now the same thing pretty much applies to 9, but this time it's going to be 3 factorial, because think about the number of ways in which you can arrange 1, 2, and 3. These 3 numbers, right? You can do 1, 2, 3, you can do 1, 3, 2, and so on and so forth, right? So there are 6 possible combinations, 3 factorial, and so that's our answer. So now we are just gonna make this into 10. And so yeah, adding together 10 plus 5 equals 15. Great! So now let's move on to the second part. How many 5-digit number are there whose digits sum to 39? This is a more difficult question altogether. But it's pretty much a repetition of the same thing, so we can consider... well, first of all, let's consider the extreme case, right? Let's consider 3, 9, 9, 9. So that's already 5 cases. It's actually quite difficult because there's a lot of cases to consider. Instead of considering 9s, maybe we can consider 6s, because the value that you need to subtract from the 9s is 6. And so what if we just consider ways in which we can distribute the 6 across the 5 digits? So for example, the example that I showed right now, 39999, would just be 60000. That might make it a bit easier to sort of conceptualize. Great. So first of all, let's clearly write this as 5. And so the next option is 51000. And of course, there are four places to put the 1, and then there's 5 places to put the 5, so this ends up being 20. Next is 4. So 4 we have 2 options. We've got 1, 1, or we've got 2. So it could either be 42000 or 1100. So here we can... This is obviously also 20. This, I believe, is 4 factorial divided by 2, and then divided by 2 again. So this means it is just 3, it's 6. So 6 for this case, and then multiplied by 5 or 30. That should be right. And then we consider 3. The 3 case is difficult. Because then we've got 3000, we've got 21, we've got 111. And then this is again 20. This is altogether different. This is simply $12, I believe, because it's 4 factorial divided by 2, and then times 5, again, accounting for how 3 can move around. Oh wait, no, this isn't 20. My bad, because these two are the same. This is 60. Let's write that down first. So this is actually 5 factorial divided by 3 factorial divided by 2 factorial. So then this becomes something like 10. Yep. And finally, 3, 1, 1, 1. And this, funnily enough, is actually the exact same case as 20, because we can consider the 0 as the only bit which can move around. So we can put the 0 here, 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 here. And since that's the case, it just becomes a repetition of the previous ones. So now we've got 2, right? We've got cases where the biggest number is 2. Which means now there's 2, 2, 2. Which, again, 10, because these two are the exact same. 2, let's say 1, 1, 1, 2, 1, 1, 2. Zero. And I believe these are the only cases. Because there's no 1, 1, 1, 1, 1, because that doesn't add up to 6. Surprisingly, I believe these are the only cases. So this we can, again, simply plug one of the previous ones into. Yeah, so we know this is 5. There's only 5 possible ways of arranging this. And then this, we already did the calculations for somewhere, I believe. Have we? No, we haven't actually. So, again, 5 factorial, again, divide by 2, divide by 2, which means it is, let's see. Wait, we have done this before. We have this one. But with that, all we've got to do is add all these together. That's 45 plus 100 plus 35 plus 30. Summing these together in bits of 3, which is why it might be a bit quick. I mean, not quick by some people's standards, certainly, but 210 is the final answer. Is it correct? Now let's go tackle our lovely warm down. A study of a large population found that 40% of men were smokers and 60% were women. Of the men, 50% were smokers and 30% were women. Wait, what? Okay, say again. 40% men, 60% women, 50% men, the smokers, 30% smokers, which means also that 70% non-smoke and 50% non-smoke. What's the probability that a person picked at random is a female smoker? So that would mean 60 times 30, which is 18%, or A. Percent. I'm just not very good at multiplying. I'm sorry. So, 62%. C. Given that the person picked is a woman, it is 40%. I believe it is 40%. Should be 40%. And we've got D and we've got E. Given that the person picked is a smoker, show that the probability that he or she is a woman is 1/9. So we know that this is actually 20% of the population. We know that this is actually 18% of the population, which means that 38% divide by 18%, so 9. No. Yeah, that's why. Given that the person is a non-smoker, alright. So I find the probability that he or she is a man. Ooh. The disease of Maphotococcus affects 0.1% of the population. Oh, there's some discussion here to read. There is a blood test that gives the correct answer in 99% of people who do have the disease and 98% of people who do not have the disease. If you just tested positive, how worried should you be? Very worried because, I don't know, climate change? Okay, so 0.1%. So that means that 0.1% times 99% true, positive. False, negative, comes from only 99.9%, 0.99% of cases. And similarly, oh wait, I did. Did I? Yeah, I did it wrong. So, oh wait, no, I did do it wrong. Okay, so this is wrong. Sorry. Okay, so now 98%. So now we're looking at the people who don't have the disease. Wait, what are we doing? Okay, I've written this wrong already, I feel like. So true positive is pretty easy, right? It's just the percentage of people with the disease and with a test as 99% because they do have the disease. And people who do have the disease, so 0.1%, times 99%, these people are going to have a false negative. This, however, is going to be a false positive. This is a true negative. Yeah. Something's gone wrong here. Oh wait, no, I forgot to use these probabilities. This is 1%, sorry. Yeah, okay. So we're only interested if you have tested positive. So that means we're looking at this. So this is the percentage of population with a true positive, and this is the percentage of the population with a true negative. Wait, no. Oh wait, no, we want to look at a false positive, sorry. Okay, yeah, I'm just not very used to working with this terminology, my bad. God, I just want to multiply that shit by 2. Okay, yeah, that's how I multiply that shit by 2. And then you... let's see. Yeah, okay, so that's where we go. Yeah, okay. Yeah, the answer is not very worried because of this. So... this is definitely divisible by 3. Is this divisible by 3? I'm pretty sure it is. Yeah, it is. Okay, so... this becomes 6, 6, 6. Fuck. This is 666. And then this becomes... Yeah, so this. Then this again, obviously divides. And that is probably it. Yeah, that's it. So that's the probability. Probability of P is this. Very high. Yeah. We did it! Okay, let's read. Blood tests are never 100% accurate. You can have false positive and false negative. A sensitivity is the ability to identify correctly patients who do have the disease. Good! The specificity of the test is the test's ability to correctly identify patients who do not have the disease. Yeah. These are just examples, and that is the stream. Huh. That's like the quickest stream I've ever done. Probably because I stopped fucking around and actually did the questions quick. Yeah, I mean, it's still 40 minutes. It's still quite a lot. Maybe I'll bother with putting up a proper thumbnail for this at some later date, but honestly, nah, I can't really be asked. Yeah, so that's step support assignment 6. I know it says 7 right now because I'm about to move on to the next one, but thank you for watching and have a wonderful evening or morning or night. And let's be honest, math nerds don't really wake up at a normal time, so I'm gonna assume it's night and it's like 3 a.m. You're just watching Lazenly step support videos because you're just a huge fan of the content. Yeah, have a good sleep. I don't know. Unless you're not. Bye.